Dear all, this lecture deals with the third set of parameter known as transmission parameters or ABCD parameters. Okay, so transmission parameters or ABCD parameters, it is otherwise known as chain parameters. These parameters are otherwise known as chain parameters, and this is actually representing the input voltage and input current, in terms of output voltage and output current. So here you have a minus sign. So input voltage V1 and input current I1 are represented in terms of a output voltage V2 and output current I2. Okay, and in equation form I can write like V1 is equal to A V2 minus B I2, and I1 is equal to CV2 minus D I2, or in matrix form I can write like the vector V1 I1 is equal to the matrix ABCD into the vector V2 minus I2, and this particular matrix ABCD is known as the transmission matrix. This matrix is known as the transmission matrix of the transmission parameter or ABCD parameter. Now how I can find the values of different parameters is that, as we have seen in the Z parameters and Y parameters, first of all, if I am making I2 is equal to 0, from equation 1 I can write V1 is equal to AV2 and I1 is equal to CV2. So, okay, so from this thing, that means V1 is equal to AV2, I can solve for A is equal to V1 by V2. That is obtained by making I2 is equal to 0. Same way I am getting C is equal to I1 by V2 and at I2 is equal to 0. Okay, so for by making I2 is equal to 0, I am getting A is equal to V1 by V2 and C is equal to I1 by V2. Actually, A is the ratio between the input voltage and the output voltage. Therefore, it is known as the reverse voltage gain. The parameter A is known as reverse voltage gain. Okay, reverse voltage gain. Reverse voltage gain is a parameter A, that is V1 by V2. It is known as a reverse voltage gain with the output port open circuited. Output port open circuited means I2 is equal to 0. Same way C is obtained as I1 by V2. I is the current and V is the voltage. Therefore, it is giving the admittance. Since I1 is a current at the input port and V2 is a current at the output port, it is representing the transfer admittance with the output port open circuited. Okay, so this is the transfer admittance from port 2 to port 1 to port 2. Okay, so transfer admittance. Now the second case is I am going to make V2 as equal to 0. So if I am making V2 as equal to 0, I can write the equation as V1 is equal to minus B into I2 and I1 is equal to minus D into I2. Okay, so from this equation V1 is equal to minus B into I2, I can solve for B is equal to V1 by minus I2 or minus V1 by I2, and from I1 is equal to minus DI2, I can write D is equal to I1 by minus I2 or minus of I1 by I2. Here B is actually the ratio between V and I, but V is the voltage at the input port and I is the current at the output port. Therefore, this is known as transfer impedance. Transfer impedance of the network with the output port short circuited. Okay, and D is actually minus I1 by I2, therefore it is known as the reverse current gain. It is a current gain but not I2 by I1, it is I1 by I2, therefore it is known as reverse current gain. So we have ABCD parameters, 4 set of parameters are there, A, B, C and D. A is the reverse voltage gain given by V1 by V2. B is the transfer impedance given by minus V1 by I2. C is the transfer admittance given by I1 by V2, and D is the reverse current gain given by minus I1 by I2. Okay, so these are the ABCD parameters. Now we have to study about the units of the parameters A, B, C and D. So here we know that A is a voltage gain, therefore it is dimensionless. D is the current gain, reverse current gain, therefore it is also dimensionless. But what is B is? B is actually the transfer impedance, therefore its unit is ohm, and C is the transfer admittance, therefore its unit is Siemens. Okay, and we are calculating the parameters A, B, C and D like by making I2 as equal to 0 means input port open circuit, not input port, output port open circuit. If output port open circuit, I will be getting A and C. Okay, now if I am making V2 as equal to 0, V2 is equal to 0 means output port short circuit. If I am making output port as short circuit, I will be getting B and D. B is equal to 0. So these are the conditions for finding the ABCD parameters, and these are the units representing that. Okay. Here you have to study about condition for reciprocity. So here also you have to consider the case of excitation and response on the input side as well as the output side. So first of all, I am considering the case 1. I am taking the two-port network and I am connecting my response excitation at the input side. So here I have Vs and here I have the current I1. Okay, now I am considering the second port. Second port I am taking the response I2 dash is here. I2 is the current flowing through the second port. So this is a two-port network. So from here I can write, as in the previous case, I can write V1 is equal to V of S and my I2 is equal to minus I2 dash and V2 is equal to 0. Okay, V1 is equal to V of S, I2 is equal to minus I2 dash and V2 is equal to 0. Therefore, from the equation, I can write V1 that is equal to Vs is equal to B into minus B into I2, that is same as B into I2 dash. Okay, so from equation 1, that means from the equation of V1, I can write V1 is equal to Vs equal to B into I2 dash, and I can solve for Vs by I2 dash is equal to B. Okay, so this is the condition ratio of voltage and current if the excitation at the excitation is at the input side and we are taking the response from the output side. Now I am taking case 2. In case 2, I am moving my excitation to the output port. That means I am connecting the excitation here. I have Vs here and I have the current I2 here flowing through the port 2, and here I have my response I1 dash, where I1 is the current flowing through port 1. Okay, so this is the same two-port network, and from this circuit I can write my V2 is equal to V of S, V1 is equal to 0 and I1 is equal to minus I1 dash. Okay, so from second equation, for this equation of I1 is CV2 minus DI2. If I am taking that equation, I can write I1 that is equal to minus I1 dash is equal to C into V2 minus D into I2, that is equal to C into V of S minus D into I2, that is equal to what? I1 dash. And from the equation, that means from first equation, V1 is equal to 0, therefore 0 is equal to A into V2 minus B into I2, and from this equation I can solve I2 is equal to A by B into V2. Okay, so I am getting I2 is equal to A by B into V2 or A by B into Vs, and from the second equation I am getting I1 dash is equal to CVs minus DI2. So I am repeating here my I2 is equal to A by B into V2 or A by B into Vs, and minus I1 dash is equal to C into V of S minus D into I2. If I am substituting for I2 here, I can write C into V of S minus AD by B into V of S. That means I can solve for the ratio Vs by I1 dash is equal to B divided by AD minus BC. Okay, so I am getting Vs by I1 dash is equal to B divided by AD minus BC, and Vs by I2 dash is equal to B. Vs by I2 dash is equal to B. So I am writing here in the first case I have obtained Vs by I2 dash is equal to B. And the condition for reciprocity or the reciprocity theorem states that Vs by I2 dash will be same as Vs by I1 dash. If that is true, then I can write B is equal to B divided by AD minus BC. So if I am solving, I can write AD minus BC equal to 1. That means the condition for reciprocity of a network in terms of ABCD parameter is that AD minus BC is equal to 1. Okay, next we are going to deal with condition for symmetry. So here you have to do like this. Case 1 is you are making the output port as open circuit. Output port open circuit means your I2 is equal to 0. If your I2 is equal to 0, I can write my equation V1 as equal to Vs as equal to A into V2, and the second equation I1 is equal to C into V2. So I can take the ratio Vs by I1 is equal to A by C. So that is the first case. And in second case, that means for case 2, I am taking my I1 is equal to 0. I1 is equal to 0 means input port open circuit. So first I am making output port as open circuit, and second case I am making input port as open circuit. Therefore I am getting I1 is equal to 0. If I am substituting this in the normal equation, I can write C into V2 is equal to C into V of S is equal to D into I2, since we have I1 is equal to 0. Okay, in the second equation I can write CVS minus D I2 is equal to 0. Therefore CVS will be equal to DI2. From this equation I can solve for V of S by I2, that is equal to D by C. Okay, so this is a condition obtained in the case of when I am making I2 as equal to 0, and this is the condition obtained for I1 as equal to 0. So for making the circuit symmetrical, I need to make the ratio Vs by I1 as equal to Vs by I2. If that is the case, I have my A by C is equal to D by C. That means my A should be equal to D. So the condition for symmetry of a two-port network in terms of ABCD parameter is A is equal to D. The condition for reciprocity is AD minus BC is equal to 1. So that's all with ABCD parameters. Thank you.